So January 2019 paper. In the first question, the unit of a charge is coulomb. Which of the following is equivalent to coulomb? So because the current is charge divided by time. So charge equals current multiplied by time. So current is ampere and time is second. So it will be ampere second. So A should be the right answer for this. In question 2, in the combination shown, each resistor is 6 ohm. Which of the following could be a total resistance between X and Y? So this one is 6 ohm, this one is 6, this one is 6. So first, the two are in parallel. If these two are in parallel, the ratio will be product, like the resistance will be product divided by sum. So we multiply 6 multiplied by 6 divided by 6 plus 6. So 36 divided by 12. So that is 3. So the combined resistance of these two is 3 and plus 6. So that makes 9. So C will be the right answer. In question 3, X, Y, and Z are representing the three perpendicular directions. The polarized light is traveling in the direction of Z. So this is the direction of propagation. Which of the following describe the direction of oscillation of polarized light wave? So direction of oscillation, which direction it is oscillating? So like example, if Z direction it is moving, so direction of oscillation should be perpendicular, like 90 degree, but it can be anywhere, any direction, but it should always be 90 degree to the direction of propagation of wave. So options, which of the following describe the direction of oscillation of polarized light? It must be in direction of X. No, it can be in X, it can be in Y. They must be in the plane which is perpendicular to X. No, they are not plane perpendicular to X. They must be in a plane which is perpendicular to Z. They must be in Z direction, plane polarized light. The direction of the wave and the direction of the vibration should be 90 degree. So they must be in a plane which is perpendicular to Z. That is right. So D is the right answer. So polarized light is having one component, and that is the vibration is perpendicular to direction of propagation of wave. The circuit shows a cell with the electromotive force, internal resistance R are connected to a resistor R. The current in the circuit is I. Which of the following is an expression for terminal voltage? Here voltage B. So the total EMF is equals to voltage drop internally. The total EMF is equals to voltage drop internally plus voltage drop externally. So total EMF is E, voltage drop internally, that is V is equals to IR. So voltage drop internally will be small IR and voltage drop externally will be capital IR, because resistance is R and the current I and the same current flow through the internal resistance. This IR is given by a formula V, because we have the formula V equals IR. So I can say EMF is equals to IR plus V. This V is added, other side will be subtracted. So EMF minus V is equals to IR. So EMF minus which terminal voltage we need. So this is V. So EMF minus IR is equals to V. So which expression EMF minus IR? So that is equal to D. So that's why D is the right answer. The equation I equals NQVA is a transport equation. When a temperature of a metallic conductor increases, which quantity decreases? For metals, this N will remain constant. It only changes for semiconductor. For Q, even conductor, semiconductor, insulator, Q is a charge of 1 electron that remain constant. Drift speed, when we increase the temperature, the particle, even if it's a conductor or semiconductor, when we increase the temperature, the particles move randomly, so the drift speed will decrease. And when we increase the temperature, if the wire expand, so it depends on the expansion that increases the area, but we assume that the area also remain constant. So C is the right answer, that increase in temperature will reduce the drift speed. And this drift speed will decrease for conductor as well as semiconductors. The beam of an electron is directed towards a thin sheet. Electron passes through, so we see a diffraction pattern. So what this gives an idea that this electron, when it is passing through, it is giving us the same result like a wave. So what we can say about this, electron behave like a particle, electron is a particle here. Light behave like a wave, light is wave, like this is not relevant to the question. The atom in the crystalline materials are arranged in circle, no. Basically what happened when these atoms are arranged, when electrons are passing, they are acting like a wave. As a result, when they passes through this gap, the wavelength associated with the electron matches with the gap size, so we'll observe diffraction. And why a pattern of a diffraction is there? So this is an evidence that within the metal, the particles are, or within the solid, the particles are arranged in a regular manner or ordered structure. So the crystalline material is having an ordered structure. That's why when electron is passing through it, the gap size is equal to the wavelength associated with the electron. So it is a diffract. So this experiment also given evidence that electron is behaving like a wave, not particle. Otherwise, if electron was behaving like a particle, then what should happen? Either it should go straight or deviate or change the direction. Which graph shows the current with the potential for an ohmic conductor at constant temperature? Ohmic conductor means it obeys the Ohm's law. If obey the Ohm's law, means the ratio between voltage and current should be constant. So A is the right answer. Thermistor, filament, LDR, these are non-ohmic components which does not follow the Ohm's law. The photograph shows a wave in a ripple tank which is passing through a gap in a barrier. Which of the following properties of a wave is being demonstrated here? So when the wave passes through a gap, what we observe diffraction, which is a bending of a wave around the edges. In question 9, light travels through air and it enters a glass block. Which of the following quantity does not change when the light enters? The frequency of a light remain unchanged when it moves or travels from, or frequency of a wave remain unchanged when it travels from one medium to another. In question 10, 4 different types of lamp produce the same brightness. The power consumption and the current are marked on the packaging of each lamp are shown. Which type of lamp has the greatest efficiency? So how we can work out? Efficiency is the useful power output divided by total power input multiplied by 100. So these are the powers. So we can work out, because to get the useful power, we have to work out the voltage for the supply. 4 different lamps are there. They're producing the same brightness. So output power is same, we can say. And these labels are refers to the input power. And the current mark on the packaging of each lamp is given. The power dissipation P is equals to I square R, means the one which draw the greatest amount of current. So they all are giving the same output. Like you can consider any fixed value as an output. Example, I consider, because as they mentioned that the brightness is same. So if they all have the same brightness, it means the power output is same. If I consider the power output to be 2, so efficiency or any value, efficiency is equals to useful power output divided by total power input multiplied by 100. So it means the one which is having the least power input, because power output is constant. So the one which is having the least power input will have the highest efficiency. So which one is having the least power? When we check 60, 12, 48, and 6. So LED is taking the least power input or having the lowest power input. So that's why it will have the highest efficiency. Because power output is same. Why the power output is same? As I mentioned, they all are giving the same brightness. So same brightness means same power output or same amount of energy every second from each type of the lamp. But because LED is taking less amount, so input power is less, that's why it shows that it will have the highest efficiency.